is a big probability distribution problem. So I have the probability of distribution of the random variable x, and then I want to ask you a bunch of probability questions. So after we finish all the probability stuff, I want to show you a very amazing skill. We can do a lot, we can do an amazing job using your graphing calculator. So let's take a look at the problem. So we have a random variable x, so x has that many distinct outcomes, and then each outcome has its own probability. Now I want to ask you a bunch of questions. So the first one is, what is the probability that x is at most? At most means no more than 3. So what is at most? How do you write the inequality? So at most is the maximum is 3, right? Including 3. So x is less than or equals to 3, right? So there is no 3, right, in the table. So what value should we choose? So what kind, look at the x, look at the first row. Which x is less than or equal to 3? So there are a few. So we have a 2, we have a 0, we have a -7, we have a -10. They are all less than or equal to 3. And then, so that is the probability that we have to add. So the first one is 0.05, and then plus 0.10, plus 0.07, and then plus 0.13. So we have a 20 plus 10, 30, 35, right? So the first probability is equals to 0.35. And then the next one is no less than 1, which is at least 1. So at least means 1 or more, right? So x greater than or equal to 1. I know there is no 1 in the table. That is okay. Tell me which number is greater than or equal to 1. We have a 2, we have a 5, we have a 6, we have an 8, we have a 9, right? That means we have 5 probabilities to add. So probability of 2, probability of 5, probability of 6, not 20, not 26, 25, and then probability of 8, and then probability of 9. So the sum is equals to the probability that x is at least 1. So the sum of that is equals to 0.7. So for the at least and the at most, I have all the commonly used adverb and phrases in statistics typed it up for you. So if you are not good with this, so you better write down this. So at most n means the maximum is n including n itself. So the inequality is x less than or equal to n. Maybe we can make this bigger so we can, but that overrides the word. And then at least n means the minimum is n, including n itself. So we have x greater than or equal to n. For the at least and the at most, we have to use the equal. For the more than and less than, there is no equal. So more than n is just greater than n, no equal. Less than has no equal as well. And then the no more than, the opposite of more than is less than or equal to. So that is just like the at most. So we have x less than or equal to n, and then no less than n, no less than, the opposite of less than is greater than or equal to, which is same thing as at least. So we have x greater than or equal to n, and then the last two, we have one inclusive and then one exclusive. Inclusive means there is an equal. Exclusive means there is no equal. So if you are having trouble with this, you better write this down right now. All right, so let's move on to C. So in C, what do we have? In C, I am asking for at least 0, at least. So what is at least? C, we have probability that x is at least, that means greater than or equal to 0. So greater than or equal to 0, that includes 0, 2, 5, 6, 8, and 9, right? So we have 6 probabilities to add. Is there a shortcut in here? The answer is yes. Look, you add from 0 to 9, you add those 6 probabilities. Look at the table. From 0 to 9, you add those 6 probabilities. The one that you did not add is the -10 and -7. So I will be using complementary event. The idea is you run 0, 2, 5, 6, 8, 9, 5. You can add them. You can add them. First of all, you can add them. You will get the same answer. No one will take points off, but I want to use a smarter way to do it. The smarter way to do it is using complementary event. You didn't take -10, you didn't take -7. I will just use 1, subtract them. So that is equals to 0.8. If you add the other 6 probabilities, yes, you do get 0.8 and you will not lose a single point. So that will be a part C. And then part D is greater than 0. So D is just probability x greater than 0. So greater than 0 means we have 2, 5, 6, 8, and 9, right? Not including the 0. So what I did not include is the -10, the -7, and the 0. So it is more convenient to subtract 3 probabilities than adding 6 numbers. So I will take 1 minus 0.13 minus 0.07 minus 0.10. So that is 1 minus 20% minus another 10%. So that is equals to 0.7. So see how convenient that is. And then part E is less than -6, but we do not have -6 in the table. So -6, so E is probability that x is less than -6, so that includes, there is no -6, right? Okay, then we have to use the -7 and the -10, so that will be the 0.07 plus the 0.13 equals to 0.20. So that is the answer of part E. So as we move down, you won't see the table anymore. So now you better take a screenshot, because as I move down, you don't see the table anymore. Did you take a screenshot? All right, then let's continue. The next one is part F. Part F, I am looking for between -1 and 5 inclusive. So that includes -1 and then x and then 5, right? Inclusive. So inclusive, which one should I take? -1 to 5. Do we have -1? We don't, but we do have 5. We don't have -1. We have 0, we have 2, we have 5, but no -1. So that means there is no -1 to take. Then you have to grab the next number that is greater than -1. So that will be 0, 2, and 5. So we add 3 probabilities, so which is equals to 0.10 plus 0.05 and then plus 0.15. So that one you have 20 plus 10, that is equals to 0.30. And then the last one is from 0 to 8, exclusive, 0 to 8. Perhaps I should just bring this table down. From 0 to 8, so F and then G. So that will be probability between 0 and 8 exclusive. That means do not include 0 and then do not include 8. So let me bring the table down right now. Wow, that is so much more convenient. So no 0, no 8, then we have to include 2, 5, and then 6. So that will be a 0.05 plus 0.15 plus 0.25. So we have a 20 plus 25, that equals to 0.45. So that is part G. And then the H, we have to find the expected value. So let's find the expected value. Still remember the formula, expected value. How do we find the expected value? So for expected value of x, so now we are start doing h. So the expected value, EX, that is equal to the sum. You take each x, multiply its probability, then you get a product. You do this for every single x, then you have many products, right? And then you add those products up. Let's write a full expression. So we start with -10 times 0.13. I will show you how to use a calculator to handle this long expression. Plus -7 times 0.07. So plus minus, that means -7, right? And then plus 0 times 0.10, that equals to 0. Write it anyway. Plus 2 times 0.05 plus 5 times 0.15 and then plus 6 times 0.25 and then plus 8 times 0.08 and then plus 9 times 0.17. Okay, so how do you handle this using your calculator? So first of all, here is how we handle it. So you have to go to the place where you enter the data. So let me go down to that page really quick. I have the instruction over there. So the first thing that you will have to do is you have to go to stat. So you hit stat. Do you see edit? You hit stat, the stat key, STAT, stat. and then you see edit, right? The edit is the place where you can enter your data. So you go into edit. I have some old data from the previous problem. How do you clean that up? So do you see the cursor is moving up and down? So you put that on L1 and then you hit clear. Again, clear. On L1, clear. And then you hit enter on your calculator. And then you move the cursor to L2, the top of L2, hit clear, and then you have to hit enter. I don't have to, but you do. On top of L2, clear, enter. So now the whole list is clean, right? So why don't you input the X to the list? Can you do that for me? -10, where is the negative key? The negative key is between the decimal point and the enter. Every time I teach this, people will just use the minus as negative. And then -7, and then 0, and then 2, and then 5, and then 6, and then 8, and then 9 is a data problem. You better check you didn't enter any mistake. 9, 8, 6, 5, 2, 0, -7, and then -10, and then we go to L2. You don't need to go to the top, and then enter the probability 0.13, and then 0.07, and then a 0.1, and then a 0.05, 0.15, 0.25, 0.08, 0.25, enter. 8 corresponds to 0.08, and then the last one is 0.17, data problem, very dangerous. Double check your entry. 17, 8, 25, 15, 05, 10, and then 7, and then 13. Now, I have X in L1 and then probability in L2. How do we multiply them? You want to take -10 times 0.13, -7 times 07, 0 times 10, right? I want to do this in one command. Now, watch. We are on the third screenshot right now. You go to the top of L3. Do you see here? You go to the top of L3. Move the cursor to the top of L3. Are you on top of L3? If you are on the first grid, you will have a mistake on top of L3. And then you type L1 times L2. So that means for each pair, you take the first data in L1 times the first data in L2. You do this for every single row. So L1, that will be second, and then you type 1, type the multiplication symbol, and then L2. You have to type the multiplication symbol. Did you get that? Can you press enter now? So now you see the product, right? So -10 times 0.13 is equals to 1.3. -7 times 0.07 is equals to -0.49. So what we have to do next is we have to add up every single product. Do we do this by hand? No, we have a machine. I am going to count on the machine. Remember, all the products are in L3, right? So now go to second mode to quick second mode on the home screen. You have to go to a place called a list. We have to do math for the whole list. So on the corner or on top of the stat key, do you see the word list? Yeah, right? You hit second and then you hit the stat key. Do you see there is an option called math? Math, right? You go to math. Do you see the fifth option is a sum? You take that. You press the down arrow. On the number 5, you hit enter, then you get the sum, right? So they are asking you sum of what? Then you give them a list. Where did you store your product? I store my products in L3, so I will hit second 3, close parenthesis, and that gives me a sum. So the sum is 2.73, which is the last screenshot over there, 2.73. So we have expected value equals to 2.73. So now I am going to go back to my writing and then finish this. So if you cannot catch the first one, you have to rewind the video and then play this again. So I will go back to my writing. So this is a 2.73, no question with that. And then for my own convenience, I am going to round this to a 3. I will show you how convenient it is. right? And then I did not ask for variance, but I want to show you how to do it. This is all about practice, right? You are watching my video because you want to learn, you want to practice. Let's do the practice. So the next one is standard variance. So for variance, what's the formula? The formula is the sum. You have x subtract the expected value, square the result times probability, right? So that equals to the first x minus 3, square the result times 0.13, and then the next x minus 3, square the result times 0.13, and then plus the next x minus 3 times 0. Oh, it's not 0.13. My bad. 0.07. And then the next probability is 0.10. You make sure you take the corresponding probability. And then 2 minus 3 square times 0.05. And then 5 minus 3 square times 0.15. And then 6 minus 3 square times 0.25. And then 8 minus 3 square times 0.08. And then plus 9 minus 3 square times 0.17. Who wants to calculate this step by step? Nobody, right? Do you want to do this step by step? What if x has 30 or 50 distinct values? Do you want to do 50 of this? If there are 4, then you are fine. 4, I can handle it. What if the table is really long? Like x has 15 or 100 distinct values. Do you want to do 100 of this and then add them up? Wow, that is going to take a long time, right? So since we have our machine, don't worry about it. I will show you how to do it. It doesn't matter how long the table is. We can get it 100% right. So let's go over there. So that equals to a number. I will come back to that. So this is how you do the variance. So now we go back to the list. So we go to stat and then we go to edit. So now you have x in L1, probability in L2, the product in L3. I will have to use my L4. Okay, so put the cursor on top of L4. What are we trying to do? What we are trying to do is, watch what I'm writing right now. I am trying to take an x, which is L1. Your x is in L1, right? And then subtract expected value. This one, you have to type the number, which is 3, and then you square the result. You multiply probability, which is in L2. And then you want to do this for every single row. All right, so let me do the typing. Second one, minus expected value 3, close parenthesis. Please close parenthesis. If you don't close parenthesis, look at my screenshot. If you don't close that parenthesis, you square the 3, the whole thing will mess up. Square. All right, and then after the square is done, you multiply by 2. Oh, sorry. Not multiply by 2. Multiply L2, second 2. So you take x in L1, subtract the expected value, square the difference, so you can get rid of all the negatives, and then you multiply the probability. And then you press enter. You see we have the product of every single terms in here. So let me go back to that real quick. So you don't have to pause the videos. So do you see that there is a multiplication? So multiplication results in a product, right? So the products, they are all right there. I don't need to do this one by one. And then what is the formula? The formula has a sum, right? So the sum means you have to sum up L4. So now you go to second mode to quick. You type second stat, and then you go to math. You select the sum, second 4 for L4. And then that is equals to 40.89. So the variance is equals to 40.89. And then the standard deviation, second you hit the x square key, you type 40.89, that is around 6 point something. So let me go finish my stuff. I will come back to this screen. Don't worry about that. So that is equals to 40.89, and then we have the standard deviation is equal to the square root of 40.89. Is simple. You have to write out, which is around 6.39, right? So that is the end of this long computation. So now you know how the calculator works on this. So don't worry about how long the table is. I don't care. how long the table is. I don't care how annoying those numbers are. I have this method. I can always get the expected value, variance, and standard deviation 100% correct. Without writing a single number down, we can get that right. So this is very beneficial if you are doing problems online, because you don't need to show your work, right? When you do problems online. So we come back to that. So now it's time to explain all the numbers. So first of all, we have expected value equals to 3. What does that mean? That means every time I repeat this experiment, I expect to get a 3. Okay? Every time you repeat the experiment, you take an action in this experiment, you expect to get a result equals to 3. All right, and then the variance is meaningless, and then the standard deviation, we have a 6.39, right? I will just round this to a 6, so it's for my convenience. So x equals expected value equals to 3 is only a point estimate. So let's give you an interval estimate. You take the 3 plus or minus 6. 3 minus 6 is equals to negative 3. 3 plus 6 is equals to 9. So that means every time you take an action in this experiment, you will get a result somewhere between negative 3 and 9. So that is way more flexible, right? Again, expected value. You are using one number to guess another number. We call that a point estimate. And then the interval I just drew is called interval estimate. I am using a set of values to guess one number, which is way more efficient. All right, so that will be the end of this lesson. If you tell me, how was it? Do you like it or you don't like it? Do you like the way I introduced the calculator? If so, let me know in the comment section below. I appreciate your help really much, especially if you can subscribe, like, and share the videos for me. Signing out for now. See you in the next video.